Hello. Now we'll go with balancing of redox reactions, ion electron method, basic medium. Basic medium is very interesting. Students get often confusion. One very interesting reaction will take P4 in the presence of basic medium, PH3 and H2PO2 minus. This reaction we need to balance. First of all, we should know that it is a disproportionation reaction because oxidation state of phosphorus is here 0, pH3 it is -3, here it is +1. 0 to -3 decrease in oxidation state reduction, 0 to +1 increase in oxidation state is oxidation. Correct? P4 0, pH3 phosphorus oxidation state is -3, so reduction it is oxidation, hypophosphite H2PO2 minus is. So we need to balance this one. This kind of reactions are called disproportionation reactions. Disproportionation reaction. So this reaction I will write like two parts, oxidation half and reduction half. P4 gives rise to PH3. P4 gives rise to H2PO2 minus. Here your common sense is most important. We are balancing. Our job is to balance the atoms. Here it is in the form of P4. Why? What is the need to take P4 as it is? However, we are balancing. Let us take P only. Why P? Why not P4? If you take P4, this is P4. So first of all, you need to make it 4pH3. When it is 4pH3, number of hydrogens will become 12. So all the numbers are going to increase. 4 times increasing. If you are taking P only, then you can ask me how can you take P? I will take here P. Final expression I will give you in the form of P4 only, right? If you're not getting P4, then okay, that's my problem. I will take care of that. Okay, definitely you'll be getting in the form of P4 only, 100%. Believe me. Okay, so to make the reaction very simple, don't say that sir P4 is then a P2. There is no use if you are writing P2. I'm not saying that that's wrong. P4 is the existing way. P4 the phosphorus exists and we are balancing, we are taking only P. Now you can ask me, P won't exist now. True, P won't exist, but we are making it for our easy convenience and not to make the 4 times reaction. For example, you see here P4, if you make, you first step you need to make here 4, then number of oxygens will become 8, so you need to add here 8H2, the number of hydrogen, everything will become 4 times. So simple way will make, that is P and P. So which is reduction, which is oxidation? 0 to -3, this is reduction, and obviously this will be oxidation. So we'll go with this. If you want P4 also I will give you, later we'll see. PH3, 1 phosphorus, 1 phosphorus, 1 phosphorus, 1 phosphorus. So phosphorus atoms wise it is already balanced. I will give you once again. If you write here P4, you need to make it 4. If you write here P4, you need to make it 4. But I am saying, you just believe me, you take P. It is right. First step is done. Next step, oxygens. Oxygens purpose, if oxygens are short, you need to add water. It is very similar to the acidic medium method. Add water. In this case, no question of oxygens, so keep as it is. No changes. In this case, P, here 2 oxygens are present. When 2 oxygens are here, you need to add 2 H2O. H2PO2 minus. Right? Now the twist comes, that is hydrogens. When you are balancing a hydrogen in acidic medium, you add just simply H plus. But this is basic medium. You don't have any H plus. You have only OH minus. So don't blindly add OH minus. Okay, now add one simple technique. If H plus, if hydrogens are short, add water. Immediately opposite side add OH minus. If hydrogens are short, add water. Immediately opposite side add OH minus. Why? Common sense, you see. H2O when you are adding HHO. Opposite side, when you are adding OH, OH you are adding. That means you added only hydrogen. Got it? When you are adding water, HHO, opposite side OH minus OH. That means oxygen, oxygen, hydrogen. That means the net meaning is you are adding only hydrogen. Got it? Now you see, 1 2 examples. When you solve, it will become easy for you. 3 hydrogens are here. So what I was telling you is, okay, this I am taking out. Hydrogens balancing. Okay, now this also I will take out. Easy purpose will go. Phosphorus, pH3 are there. 3 hydrogens are here. So what I told you is add 3 H2O, opposite side pH3 plus 3 OH minus. I write always OH minus in brackets. Otherwise, what happens is, after a few days, students will think this is 30 H minus. Then later they think H minus, how it is possible, it will become H plus. All nonsense will go. Simply you keep OH in brackets. No question. Okay. 3 H2O, this said 3 OH minus. Now you can check clearly. 6 hydrogens are here, 3 and 3. 3 oxygens are here, 3 oxygens. Everything is settled now. So P plus 3 H2O gives us to pH3 plus 3 OH minus. What about this side? Here 4 hydrogens are there. Here already 2 hydrogens are present. 4 hydrogens, 2 hydrogens. So you need 2 hydrogens this side, right? P plus 2H2O gives rise to H2PO2 minus is your equation already. Here 4 hydrogens are present. Here 2 hydrogens are present. You need to add 2 hydrogens. So I am adding here 2H2O. This side 2 OH minus. Okay, this arrow will keep bigger. Phosphorus, 4 hydrogens this side, 2 hydrogens this side. So I am adding 2 H2O, opposite side immediately 2 OH minus. If you want, you can check. Phosphorus, done. 4 plus 2, 6 hydrogens are there. 2 here, 2 to the 4. Oxygens you can check better. 2 and 2, 4 oxygens. 2 here, 2 here. Got it? Now we'll go with charges. P, no charge. H2O, no charge. pH3, no charge. 3 OH minus, minus 3 charge. So this side 0, this side minus 3. Minus 3 will come this side, will become plus 3, means this side you need to add 3 electrons. P plus 3 H2O plus 3 electrons gives rise to pH3 plus 3 OH minus. P plus 3 H2O plus 3 electrons gives rise to pH3 plus 3 OH minus. In this case, we'll see 0 charge, 2 minus charges. Minus 2 charge this side, this is 1 minus charge, H2PO2 minus 1 minus charge. Don't forget the charges. Otherwise, your answer will go definitely. Okay. Minus 2 and minus 1. So this will minus 2. Smaller number, it comes here plus 2. Means you need to add 1 electron this side. So P plus 2 H2O plus 2 OH minus gives rise to H2PO2 minus plus 2 H2O plus 1 electron. In this case 3 electrons, in this case 1 electron. So what you need to do is this equation must be multiplied by 3. This equation by 1. So they don't need to multiply. Just simply write the equations now. P plus 3 H2O plus 3 electrons gives rise to pH3 plus 3 OH minus. Fine. Multiply by 3 and write here 3P plus 3 to the 6 H2O plus 3 to the 6 OH minus gives rise to 3 H2PO2 minus plus 3 to the 6 H2O plus 3 electrons. Correct? See? 3 electrons cancel. 6 H2O cancel. 3 OH minus 6 OH minus, you can cancel this and 3 OH minus remaining. Over. What is left? P and 3P. P and 3P means 4P. 4P, I can write like P4. I promised you, I will give you P4 and this is P4. 4P, I am writing like P4. 3H2O plus 3OH minus gives rise to PH3 plus 3H2PO2 minus. It is the balanced equation. You can check left hand side, there are 3 OH minus, that means 3 minus charges are present here and 3 minus charges are present here. This is one wonderful equation. Phosphorus when reacts with base like sodium hydroxide, it gives you PH3 and H2PO2 minus. One very interesting reaction. This is disproportionation, one type of redox reaction. Reduction half, oxidation half. The only important point is when you are balancing hydrogens, you are not using your H plus ions, you will be adding H2O, oppositely immediately OH minus ions. Check carefully. 3 hydrogens are there. So 3H2O, 3OH minus. This said 4 hydrogens, this said 2 hydrogens. So we are in need of 2 hydrogens. So we added here 2H2O, immediately 2OH minus. Don't confuse. Practice. If you have any doubts, message me.